G'day, my name's Chris Muir, I'm an ADF Product Manager and welcome to yet another episode of the ADF Architecture TV channel. I hope you've subscribed to the channel and you're receiving notifications about our new episodes because we've got plenty of good more material to come. We have a lot of other Oracle presenters ready to start presenting to you, so go and hit that YouTube subscribe button now. Okay, so in today's episode what I want to talk about is what I call inter-task load navigation patterns or options. Now what we're not going to talk about in this episode is all the different ways that task flows communicate with each other. So task flows passing parameters around, using contextual events and parent actions. In fact, in the next set of episodes, Frank Nymphius is going to have a bunch of episodes on inter-task load communication patterns where he will address all of those concepts, and they're very powerful ones. They're some of the most flexible options in allowing task flows to communicate to each other. Now, what we're going to talk about in today's episode is, well, two things. First of all, we know with unbounded and bounded task flows, we can set up control flow cases and we can influence how the user navigates around our application. So while technically we know a lot of ins and outs about task flows, I want to take a step back and talk about how, when you put your task flows together, you can influence the user's experience on using the application. Secondly, something that's probably not been discussed a lot before, I'd also like to talk about that when you have task flows calling task flows, and remembering the ADF framework is incredibly flexible thanks to the task flows features, the ability to have page fragments, bounded task flows embedded on other pages. Not many other frameworks had that feature. It's a very exciting way, a very powerful way for developers to build applications. But when we have this concept of task flows calling task flows, calling task flows, calling task flows, this incredible flexibility, this empowering developer concept must have a cost associated with it. So what I want to talk about is the performance impact of having task flows, calling task flows, and so on and so forth. And then what I want to talk about is the different options or patterns that you have for how task flows call task flows, and how you can potentially get around some of the memory and CPU footprint issues, but why you would and you wouldn't want to. So there's some interesting discussions coming up on how task flows actually integrate with each other. So let's first though discuss how, when using unbounded or bounded task flows and setting up the navigation options within those, we can actually influence the user experience in using our application. So let's discuss some of the navigation characteristics of unbounded and bounded task flows. Now we know from the name unbounded versus bounded task flows is that the bounded task flow, very much the navigation structure within the bounded task flow is defined and the user can't skip any part of that logic. But with the unbounded task flow, everything's up for grabs. Basically, an unbounded task flow, there is no defined entry point into any of the activities within the unbounded task flow. As long as the user has the URL, or let's say a bookmark of one of the activities within your unbounded task flow, they can navigate to that, and that means any activity in your application, in your UTF as such, can be a starting point for your application. In addition, the navigation model then, the number of steps that the user can take in order to get to any activity on the unbounded task flow is, well, the minimum is 1. Though, of course, you can also, in addition, set up navigation rules within your unbounded task flows such that if the user lands on activity A and you have set up navigation rules to activity B, then those control flow cases will allow the user to navigate across the activities. But if the user happens to have the URL, bookmark URL of the second activity, if they've left the application and then in their browser they hit the URL of the second activity, they can bypass the first activity altogether. This is the point, unbounded task flows. It's all about free-form navigation. Another important thing to understand about unbounded task flows is, because of this free-form navigation, is if you have an isolated activity, that is an activity that doesn't have any control flow cases coming to it and doesn't have a wildcard associated with it, it's not actually isolated. Because again, as long as the user has the URL to that activity, they can get to it. Now, how they find out about that URL is a different question. Maybe they don't know about it, so that will make it a little bit more difficult. But from a technical perspective with unbounded task flows, for every activity, it doesn't matter if they have control flow cases going to them, wildcards navigating to them or not, the user can get around every part of the unbounded task flow. Now let's consider bounded task flows. Now, as the name says, unbounded task flows, freeform navigation is available to you. With bounded task flows, no, you very much more structure the flow in your applications. In terms of bounded task flows, you will define a single entry point to your bounded task flow. Then you will define at design time a flow or a set of logic through your unbounded task flow, and then a number of exit points through your task flow using task flow return activities. Bounded task flows are much more structured than unbounded task flows. It's not possible for users to skip to particular activities using URL parameters. It's all about structures and flows to suit business processes. Let's articulate that a different way. When building business applications, it's very important that the programmer controls the flow of users through the overall application. If you think of a student enrollment system for universities where we need to identify the student, capture their address and billing information, and then enroll in some units, if we allowed the user just through the equivalent of the unbounded task flow to skip parts of that overall flow and just go and enroll in some units, we wouldn't know who they were, we wouldn't know who's going to turn up to our classes, and we couldn't charge them any money. So we need a much more structured way of putting our applications together, and that's where bounded task flows come in. Single entry points, a defined flow through a number of activities, routers, method calls, and a number of exit points out of that particular bounded task flow. From my perspective, bounded task flows remind me of 3GL functions. If you think about 3GL languages, you can call functions, pass in a number of parameters, and then you have an algorithm with a number of if and conditional type statements. You can do logic, you can call other functions. Hey, we can do that in bounded task flows. We can call other bounded task flows. And at the end of the actual function, you have a number of return statements which can return data to the caller. This is something that bounded task flows have, a very structured way of doing web programming, and it's a very powerful construct within the ADF programming environment, particularly for business applications. Now, in talking about bounded task flows, unlike their competitor, or I should say their sister, the unbounded task flow is not really a competitor, the bounded task flow does not allow the user to skip to any activity through a URL parameter. In addition, the minimum number of steps that it takes for a user to get to any defined activity in the bounded task flow is defined by you at design time, the programmer. In an unbounded task flow, if the user has a URL to any particular activity within the unbounded task flow, even though you might have defined a particular flow through the unbounded task flow, the user can just use the URL in the browser to skip straight to that activity. But in a bounded task flow, if you've defined an activity as the third step in the overall flow of the bounded activity, it will then take the user 3 steps to get to that actual activity. You've very clearly articulated the navigation model for that particular bounded task flow. Finally, unlike the unbounded task flow, if you have an isolated activity that has no control flow cases or wildcard navigation rules to navigate to it, that activity is completely isolated and redundant. In context of the unbounded or UTF, what we can do is we can give a user a URL to any isolated activity as such, and they can use it. But in context of bounded task flow, there's not much point to have any isolated activities in your overall BTFs. So given we have an understanding now of unbounded and bounded task flows and the navigation, say, constraints or lack of constraints that they give the user, we can understand that within context of those two building blocks of a main ADF application, we can change the user experience in terms of navigating around our application. But it's just not about the navigation within unbounded and bounded task flows, because we need to recognize that, well, task flows can call task flows. So in the way that task flows call each other, we also influence the navigation model and the overall user experience that the user has of our application. So broadly speaking, there's a number of different ways to have task flows called task flows and how that changes the way that the user interface actually works. But I wanted to just broadly also speak about 4 general ways that I've seen in the past that user interfaces have been put together. And you can build these type of interfaces using ADF and the task flow features. The first one is what I call the drill up, drill down interface, or you might call the stack interface. And if you come from a traditional Oracle Forms or an Oracle development background where you used Oracle Forms, you'd be quite familiar with this type of interface. What typically happened in an Oracle form system is that the screens were based around database tables. And as you know, in a relational database, the database tables are arranged in master detail relationships. And often you can have master detail, master detail, master detail, or maybe you call that master child, 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 child. And when building Oracle Forms applications, it was quite common to build a form around each one of those database tables. And it was called a block in Oracle Forms parlance. And basically what the user would do is when they arrive on the first form and they see all the data, say for departments in a table, they would double click on one of those departments and then navigate to another form screen with the previous one in the background where they show employees. And then they double click on the employee record out of a table of employees, then maybe drill down to jobs and so on and so forth. Now at a certain point, the user had navigated down this data structure, they drilled down this data structure, found the data they wanted, and then they drill back up to part of this stack, and maybe they drill off to other parts and come back around. Now, ADF isn't exactly Oracle Forms, but that way of building applications with drill down and drill up, or sort of a stack-like interface, is still very much a capability of ADF. So from a user's experience point perspective, while the application doesn't have to be built around drilling up and down a, say, data model, such as that defined by the relational database, still from a lot of systems perspectives out there, and you would have experienced this in web applications, you will find that a drill up, drill down type interface is supported. Now it's very easy to implement on ADF, it's just task flows calling task flows calling task flows, and it's a stack of task flows. Another type of interface that ADF is particularly good at, and you will see this in many desktop-like applications, but not so much so in web applications. And the reason that is because in web applications, well, they don't have quite the fantastic task flow features that we have in ADF, and that is of the wizard or train interface. You'll know in a lot of websites, when they want to get you to enter a lot of data, they just tend to give you one long page and you have to work your way down the page. But with ADF, thanks to the train type facility, we might call it a wizard type facility, we can string a number of bounded task flows together in a train, and we can have the user step through a number of steps or stops, I guess if we're going to use the train terminology, through a number of stops, and work their way through an overall business process and satisfying each stop and completing the overall process on the way. So again, by the way that we string our task flows together and we orchestrate our ADF application, we can very much influence the user experience for the user and how the application works and particularly navigates. Another interface type would be what we call the dashboard interface. Now you might call it a portal interface, but it's where you have a main page made up of a number of little portlets. Okay, and those portlets are all doing things that are independent. It's quite common, I should say, in many applications to have a dashboard type interface for the landing page where the user can see, say, the local news from the organization, maybe stock prices, maybe their tasks for the day, and so on and so forth. This screenshot here from Fusion Applications shows you very much a similar type structure for Fusion Applications users. Now again, we're very much influencing the user's navigation here, because instead of allowing them to navigate off to lots of different screens like in the drill up and drill down fashion, what we're doing here is we're providing all the information on one screen, which is very empowering. Certainly the user has a lot of information there, right there, they don't have to go off and look for it. But the flip side is as well, we're kind of saying, no, you can't go and navigate and look at bigger screens unless we build those facilities for you. Of course, you know with ADF we can support these dashboard interfaces quite well, and not only can we embed bounded task flows based on page fragments into those dashboard type portlets, but within context of each bounded task flow we can then navigate within them. So we can still do a drill up, drill down type interface just in context of one of the little portlets. It's also worth mentioning, just before I conclude, talking about how we put our task flows together and we influence the overall navigation of the application and the user's experience, is that in context of ADF we have what we call the dynamic tab shell, sometimes known as the ADF UI or UE shell. Now the ADF UE shell is a shell where dynamically at runtime the user inside the application, not in the overall browser but inside the one browser page, they can spawn dynamic tabs, and they can have separate bounded task flows running within each of those tabs which they can switch backwards and forwards to. Now that provides a very a very interesting navigation model for the user because they're not overwhelmed by all the information in one dashboard. They can control the tabs and look at different parts of the application and different bounded task flows on each of those tabs at any one time. But from your perspective as an ADF developer, technically the ADF UE shell is just a dashboard. It's ultimately 15 task flows, so in 11G at least, it's 15 hard-coded task flow bindings behind the scenes that dynamically you can just call different bounded task flows, and all you're doing is really ultimately is allowing the user to switch visually between what's in each one of those tabs or task flow bindings. But it's a dashboard interface. So just to re-articulate it there, as you can see, with unbounded and bounded task flows, within those we can actually control the user's experience in terms of navigation. And outside of that, when we start to call task flows and task flows call task flows and so on, when we know that we also control the user's experience in terms of navigation through the application and some of the different models I just talked about. There are different ways to put applications together, but I'm just basically showing you or talking about some ones that I think are quite common and definitely I've observed over my many years of application development. Great, so now we have a good understanding of when we put our task flows together, how we construct them internally, and even how they call each other, how we can influence the overall user experience and navigation models of the application. But there is a flip side story to all of this wonderful navigation and excellent flexibility that ADF gives to us in building applications with these rich navigation models, and that is the performance impact. We need to understand that the different ways that we have task flows calling task flows and the way that they're arranged in composite task flows can actually have a performance impact both in terms of CPU and memory on our overall application. So what I'd like to do in concluding this episode today is really just talk about those different models. I'm going to talk about the stack model, the network model, a hybrid of those two. Then we'll talk about dashboard interfaces and parallel navigation and how they can have an impact on the overall navigation of your application, performance of the application, and how you have to design and architect your application. So the first inter-task flow navigation pattern is that of the stack navigation pattern. And we already described this from a user experience perspective where we have drill up, drill down type interfaces. But very much in ADF, as we've described previously, is that task flows can call task flows, can call task flows, that can call task flows. And ultimately what you're doing here is you're creating a stack of task flows. As they call each other and continue on their way, the previous task flows do not terminate. They stay in memory and control passes to the current task flow, which does its thing, and it might call another task flow and does its thing. And well, if it terminates, it then goes back to the previous task flow in the stack. And if that terminates, it goes backwards. And if another task flow goes, you're starting to build the stack again. So it's very much a stack-like interface. And again, it has a lot of similarities with 3GL type stacks. Same sort of concepts there. So yes, this is a type of interface that you can easily build in an ADF application. Now with that in mind, let's talk about one of the implications of that. When one task flow calls another task flow in the stack-like fashion, the previous task flow is not terminated. And indeed, not only is it not terminated, but its state is maintained in memory. So you might have task flow A where it's modified a bunch of variables, a bunch of ADF business components, and then task flow B is called and it might modify a bunch of managed bean settings, and task flow C is called. It's all maintained. And when the original, or I should say the top task flow on the stack is actually terminated and control returns back to the previous task flow, the state is still stored there and the user continues on as if nothing had happened. Now from a programmer's perspective, this is fantastic because you don't have to go back and restore that state as the user moves between all these different task flows. But obviously there's a disadvantage associated with this is, well, there's going to be a bunch of memory overhead associated with this particular option, because as you go deeper into the stack, well, hang on, in the stack you get taller, don't you? But you get the idea, you're going to just be multiplying the memory requirements for that particular user session. And if you have quite a deep stack in your application, so maybe 10 or 20 or 30 bounded task flows, and you multiply that by 10 or 100 or 500 users, you can see the sort of memory footprint issues you're going to get into. From the programmer's perspective, a very easy interface to build, a very easy navigation and task load set of calls to build. But from a scalability perspective, the flip side is, well, your application's memory footprint is getting larger and larger. Now, you don't necessarily want to say then, hey, throw all that fantastic functionality away and make your programmers program around this. Because for very simple applications or even medium applications, that memory footprint is still probably not very large. But for very large performant applications, okay, where we've got thousands and thousands and thousands of users, you might need to consider to bring that memory footprint down. And so therefore the stack navigation model is maybe not one for you. Something else to keep in mind with the stack navigation model is that you've got to think about the order of the items in the stack. Task flow A calls task flow B, which then calls task flow C, which then calls task flow D, and so on and so forth. Each one of those task flows is actually very tightly coupled in the order that they're all called. If later on you realize how you currently got task flow A, B, C, D, and E stringed together in a stack, you realize that C really should have come before B, you're going to have to go and start modifying the items in multiple task flows to get the correct order you want. So a stack-like interface, once you kind of define it, it becomes very hard to remove yourself from that type of structure that you've set up. This may not give you the flexibility that you need later on to reorchestrate your task flows, or what we tend to call as service-oriented development task flows, in the correct order that you need them for your application. Okay, I've blown my rule of keeping these episodes under 20 minutes, but we don't have too much longer to go. And let's now address how to solve that memory footprint issue of the stack navigation model. So the solve to that is the network navigation model. Again, just a term that I've come up. And how this works is, where we used to with our stack navigation model have all these individual task flows, rather than stringing them together, having them call each other, what you do is you build them in isolation. You build your, let's say, 5 task flows, and you have clear entry and exit points from them. Then you wrap them in a composite or a master task flow that provides, from the user's experience perspective, very much similar a stack-like experience, or the drill up, drill down interface, I should say. But what we're not doing is we're not having those task flows call each other in a tightly coupled fashion. It's only the composite task flow who knows which task flow gets called when. And it defines that, essentially, that order by the task flow navigation rules between each of the task flow calls. So basically at runtime, what happens is the composite task flow gets called, and it will then call, let's say, the first task flow by a task flow call. Now that task flow call will do its processing, then exit, returning back to the composite task flow. It will then navigate to the second task flow and drill in and do its thing. It will exit, then navigate to the third task flow, do its thing, and so on and so forth. So this is very much a navigation model where with the composite task flow, we're now controlling the order that the task flows are called. And from a performance, or particularly a memory perspective, the most amount of task flows we're ever going to have on the stack is 2. It's going to be the composite task flow and the task flow that we've called down to. So as you can see, from a scalability point of view and a memory perspective, this is a much better situation, because now we've got numerous user sessions coming in on the stack, or in memory for each one of those user sessions. Purely from the point of view of task flows, they're not going to have a very large memory footprint. But there is a disadvantage with this particular network navigation model. Now in the flow that I just described, we're drilling down, up, amongst a bunch of task flows. What happens is, in the stack task flow, when we want to go backwards to a previous task flow, well, the stack navigation model, the memory for that particular task flow, or the state for that task flow, is still there, and there's nothing that the programmer has to do to restore that state. But with the network navigation model, because that task flow that we're revisiting was terminated, well, you as a programmer need to do additional processing and add additional logic to restore that state. So we can see a typical conundrum that we have in computer programming is, often when you want to save memory, you have to give up something else, and in this case it's CPU or processing. And you can't really have both. Well, sometimes you can, but most of the times it's a trade-off in scalable systems between memory and CPU. So which one is right for you, stack versus network? It kind of depends on the application you're building. It also kind of depends on the skills of your programmers, because in the stack model, programmers don't have to build an additional code to restore state, and they don't have to do additional logic to make sure that it's all hanging together from the user's perspective. But from the network navigation model, a beginner programmer has to have a lot more knowledge about how things are working, and you're putting a lot more onus on them to get that right. So maybe for a beginner application programmer, get them to work the stack model on a smaller system, but when you get into more scalable systems and your programmers have more experience, well then you can look to the network navigation model as such. Now, of course, when you think about the stack navigation model and the network navigation model, there's nothing to say you can't have a hybrid of both. You could have a composite task flow that calls a single task flow, then comes back out and goes to another task flow that, hey, that just happens to be a stack task flow, and that goes to 10 levels deep and comes back. So with those navigation models, you're very dependent on what the programmers have built for you, and you might need to define some guidelines to ensure that, well, basically if you're trying to keep the memory footprint down, that the programmers are following the model that you described. Moving on from the hybrid navigation model, a very brief mention there, then let's talk about the dashboard type interface. And we talked about the dashboard interface earlier on in this episode, where you've got a dashboard made up of a number of little portals. Now, the dashboard type interface, thanks to the fact in ADF each one of those little portlets can be just calls to bounded task flows, well, ultimately the navigation model defined in each one of those portlets just goes back to what we just described, the stack and the network navigation model. The issue that you hit with a dashboard with a number of different portlets is, imagine you have 10 portlets calling 10 stack-based navigation model bounded task flows. And in every one of those, the user goes down to, let's say, another 10 bounded task flows deep. You can imagine now, just for one user session, the memory footprint issues that you might have with a dashboard type like interface. So you might need to consider, for a dashboard type like interface, hey, don't allow those little bounded task flow portlets to go to too many levels. Otherwise, the footprint of your dashboard, which, by the way, dashboards are typically the landing page of your whole application, tend to be one of the most busiest parts of your application, you will see the memory footprint of your dashboard explode for each user session. So you need to keep that in mind. Do also remember that the ADF UI shell, or the dynamic tab shell that we mentioned earlier on, is just another dashboard-like interface. So very much where you can support up to 15 dynamic tabs, or with bounded task flows, which could be stack-based bounded task flows, all being active for one user session, the memory footprint of that user is going to be quite large. So you need to not let things get out of control, or at least have an understanding of what we've talked about in this particular episode today, about, hey, how suddenly, by the way, the real incredibly flexible way that ADF allows you to bring applications together, how you can make a bit of a memory issue for your overall application. Two last navigation models. The inline pop-up. We know in ADF pages we can have pop-ups where you click on a button and the pop-up gets instantiated, and those pop-ups can have regions and bounded task flows in them. For all intents and purposes, it's the same discussion as the dashboard navigation model we just talked about. Finally, the parallel navigation model. You would know in ADF, when one task flow calls another task flow, you can have, via the dialog framework, that second task flow to be instantiated in a separate browser window. Alternative and equivalent to that is, modern browsers allow the user to spawn multiple browser tabs, and typically users use that to go to different websites. But what you can do in that browser is each browser tab can actually point to the same ADF application. And overall, for that browser, even though there's multiple browser tabs, from the ADF application's perspective, it is a single user session hitting the actual application server. Though ADF is smart enough to understand that each browser tab is actually a different, let's say, well, it's not a user session instance, I guess would be the best way to describe it with the overall ADF application. Now, for each browser tab, everything we've described before in the navigation models is true, right? We're still talking about stack navigation models, network, dashboard, hybrid, inline pop-ups. But where the performance aspect comes into this with the browser tabs and the ability via the dialog framework to spawn separate browser windows to access the ADF application is that, well, certainly for one user session now, we're multiplying their footprint significantly. Their impact on the overall ADF memory and CPU is much larger, as if it was, rather than being separate users, one user is really getting a large use of our overall application server now. And in addition, well, from a programmer's perspective, not only do we have to keep this footprint in mind, but we also have to code our application a little bit differently. It's very important in ADF that you make use of page flow scope beans and backing scope beans, I should say, in order to make sure that the right type of beans are being used in order to support those multiple browser tabs. Okay, I must apologise to you because this episode's got a bit longer than I wanted to today. Normally I try to keep them shorter than this. But in today's episode, I hope I've given you a bit broader idea about some of the considerations with task flows rather than just the technicalities. Now, over the ADF Architecture TV episodes, we've got some great technical information on task flows coming up. Task flow transaction options, task flow data control scope options, task flow intercommunication options, all very valuable content. But in this episode, we've seen that the way that you arrange your task flows, the actual control flow cases in the UnBounded and bounded task flows can have an influence on, well, the navigation models and the user experience of your application. In addition, how task flows call task flows, we see that there's also a performance impact associated with that. So we can have a larger memory footprint if we're using the stack navigation model or the dashboard type model with lots of task flows embedded in portlets, or the network navigation model, hey, we get rid of that memory footprint, but there is a CPU and processing cost associated with it. So from a design and architecture perspective, depending on the type of scalable application you're building, but also vice versa on the skills of your programmers, you can keep these things in mind and work out what sort of application you need to build. And does it need to be scalable? Does it need to be simple from your programmer's perspective? These are all options in front of you. Thanks very much for joining us on the ADF Architecture TV channel today. I hope you've enjoyed this episode, and we do look forward to having you in the next episode very soon.